Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. We are getting into trigonometry here today. Now, if you have a scientific or graphing calculator, I recommend that you whip it out, especially if you're following along with me on this one. Trigonometry in right triangles. I'm only planning on, I think, making 2 lecture videos using trig. This is really an introduction to trig stuff. And listen, there's going to be some stuff that's going to sound pretty confusing to you, especially in the beginning when we're not doing examples yet. But I need to teach that part before we get into the examples. So once you start seeing some of the examples and feel it out, I think it's going to make a lot more sense. But, just kind of bear with me in the beginning, if that's okay. So what is trigonometry? Then we're going to be finding side lengths. We're going to learn some what are called trig ratios, and then finding angle measures using what's called inverse trigonometry, inverse trig. So let's jump right into it, guys. Let's see, what is trigonometry? Well, trigonometry is used to describe the relationship between an angle in a right triangle and the ratio of 2 specific sides relative to that angle. Okay, let's deconstruct that sentence. First of all, the word trig. Okay, so trig is really talking about relationships, ratios, what have you here. We're going to apply what are called trig functions. Trig functions, and they will determine a certain ratio, a fraction, a division, comparing any 2 sides in a right triangle. I mean, there'll be specific ones depending on the trig function that you use. Maybe I'll use B and C, or A and C, or B and A, something like that, right? And they'll divide them. They'll divide them, and they'll compute something with that division. And it has to do with the angles involved as well, specifically the angles A and B. See, C is the right angle in and of itself, but that's all we're going to be using C for today, just knowing it's a right triangle. We're going to talk about angles A and B right here, okay? Now, when I said relative to that angle, for example, guys, a side opposite one angle isn't going to be the same side opposite another angle. Opposite angle A is side length A. Opposite angle B is side length B. So when I say opposite, opposite what, right? It's always opposite the angle we're referring to. Not like if I'm talking about angle A and I say opposite, I better not answer B as that, because that's opposite B, if that makes sense. Now, like I said, we'll be getting more into this. If you're already confused, that's kind of okay. I'm just kind of getting the terminology, and I think it's really important that you hear all this first with that. Now, guys, in a right triangle, we don't just call these sides all the time. In fact, I'm going to try and avoid saying the word sides, even though I said it here. Now I'm going to really start using the word leg, and hypotenuse. The hypotenuse in a right triangle is always the longest side of the triangle, or rather the side opposite the right angle. Now, I'm not going to say side opposite right angle, guys. I'll call this hypotenuse. For identification's sake, this will always be hypotenuse. And like I just said, it is always the longest side. As you guys know, in a triangle, the longest side is always opposite the largest angle. And the largest angle in a right triangle will have to be the right angle, because the other 2 angles will be acute. Now, these are both legs, like I said here. So legs are these sides. So what is, once again, the leg opposite of angle A? Well, that is, once again, side length A. The leg opposite of angle B is side length B. This is going to be very important for what we do. Extremely important for what we do. The leg adjacent to angle A, adjacent means next to or neighboring, but that's side length B. And the leg adjacent to angle B is side length A. Notice that I didn't say, you're like, well, hang on, C is adjacent to A. How will I know which one I'm talking about here? Well, C is not a leg. C is the hypotenuse. So that's what I'm saying, guys. That's why I'm going to call these things legs here when we talk about opposite and adjacent. But specifically adjacent, because you're right, C is adjacent to A and B is adjacent to A, but B is the adjacent leg. Okay, so this is all important. These words, opposite, adjacent, and hypotenuse are all important here. I'm going to use the same triangle going into the next slide now that you've gotten a little brief intro on trig. And I know it didn't really answer all that much just yet, guys, but I promise that we'll be seeing a little more to it. Let me just kind of say this one last part in trig, if this kind of makes sense. This trig is all about, like I said, comparing 2 sides, like dividing them, right? What we learned in the special right triangles video that I just made last is that just because an angle is twice as large as another angle doesn't necessarily mean that the side opposite that angle is twice as large as the side opposite another angle. In fact, we found out that's totally not true. We found out in a 30, 60, 90 triangle, the side opposite the 60-degree angle isn't twice as large as the side opposite the 30. It's the square root of 3 times larger. So it's actually not even true. But trig helps us answer that question, how many times larger is it, with its own ratios. Like I said, we're going to use calculators to help us out with this. So let's go back, guys. Let's now find side lengths. Let's find side lengths with this information here. After this slide, we're going to do examples. Okay, the 3 basic trig functions we will begin with, or that we're going to use here, are sine, cosine, and tangent. Abbreviated, sine looks like sin, cosine looks like cos, and tangent looks like tan. Now these 3 will likely show up on your calculator as these 3 letters here. Try and not say sin, cos, and tan though, please. Try and make sure your math teacher thinks that you know a little bit about what you're doing rather than just reading those out loud. Sine, cosine, tangent. Anyway, these, as they're called trig functions, they all give you very specific ratios within a right triangle. We'll dig into them in a second. You can use these 3 trig functions to determine the measure of an angle or side with some of the properties that you see listed below here. Okay? So, if you need to memorize these for any reason, and I won't have my students necessarily need to memorize this, you can use this as as a resource to access at any time, but there's a mnemonic device called SOHCAHTOA. SOHCAHTOA. Say it out loud with me, SOHCAHTOA. It's 9 letters, broken up into 3 sections, each of which are 3 letters each. And within those 3 letter segments, the letter corresponds to the first letter in each word that we're representing to understand the ratio for each trig function. In SOHCAHTOA, so represents sine, opposite, and hypotenuse. Hypotenuse. What this means here is when I take the sine of an angle, and we're going to get into this, but when I take the sine of an angle, it will be equal to taking the side length opposite that angle and dividing it by the hypotenuse of that right triangle. That will be the ratio when we use sine. When we use cosine, C for cosine, A for adjacent, H for hypotenuse. When you take the cosine of an angle measure, that ratio that you get out will be equivalent to taking the leg length adjacent to that angle and dividing it by the hypotenuse of the right triangle. And when you do tangent, when you take the tangent, TOA, when you take the tangent of any such angle, that will be equal to or equivalent to the ratio of dividing the leg length opposite that angle and dividing it by the leg adjacent to that same angle there. So instead of hypotenuse, use opposite over adjacent. SOHCAHTOA. Remember SOHCAHTOA. Okay? Now, this is going to be on the screen here. It's actually not going to be on the screen in future slides. So if you'd like to write this down, please do so. But I'm going to be saying SOHCAHTOA out loud. Basically, if there's something you had to memorize, you basically have to know how to spell it. So that's going to be important. Know it's 9 letters long. Know the letters that are involved with it, obviously. And then I think that's going to be very helpful for when you're doing this thing for SOHCAHTOA. Okay, what does SOHCAHTOA mean here? How do we use it? Well, okay, guys, if angle A had some sort of known measure or whatever, if we're going to do something with angle A here, and we wanted to take the sine of angle A, since sine is opposite over hypotenuse, guys, the sine of angle A is equal to taking the leg opposite of angle A, which is A, and dividing it by the hypotenuse. I'm just going to draw an arrow there, but dividing by the hypotenuse, which is C. Whatever A divided by C is the same thing as the sine of angle A. And that's something, like I said, that we're going to use in a calculator. You're going to have to be patient with me when it comes to getting to the examples that we're going to do. The cosine of angle A takes the leg adjacent to the angle, which is B, and then dividing it by the hypotenuse of the right triangle, which is C. And then the tangent of angle A equals A divided by B. That is, again, TOA, the leg opposite angle A divided by the leg adjacent to angle A. All of those are relative to angle A when I say opposite and adjacent, right? A was opposite of A. But now when we talk about sine, cosine, and tangent of angle B, why does this say B over C when this says A over C? Because leg length B is opposite angle B here. I'm still doing opposite over hypotenuse, only it's with this specific angle right here. And then ca for cosine. Cosine is adjacent over hypotenuse. Adjacent is A over the hypotenuse. Hypotenuse is always C for these things here. And then the tangent is B opposite over A adjacent right there. Okay. So if this were, hypothetically, to go back to my 30, 60, 90 thing that I was talking about to make sense of this, guys, if this was 60 and this was 30, what they're doing, if I took the tangent of 60 degrees, and you could try it on a calculator, but if I take the tangent of 60 degrees, guys, what it's going to do is it's going to take whatever this side length is right here, let's say it was root 3, divided by this side length here, let's say it was 1. It would take root 3 and divide it by 1, which is some number around 1.7 something. So if I typed tangent of 60 in my calculator, though, it would give me that same number, 1.7 something. It gives you, basically, your calculator knows what this should compare as because it understands that it's talking about a right triangle. And what it knows is specifically how the sides work relative to everything else, just based on its nature, guys. So again, you kind of trust the calculator with it. It'll give it to you. That's what we're going to do. You're going to be seeing a bunch of that there on the next page. So anyway, that's SOHCAHTOA. SOHCAHTOA is not going to show up on the next page, guys. We're going to do that. You might have noticed, once again, as I said, I'm not taking sine, cosine, and tangent of angle C. There are answers to it. You can have your calculator help you. You might not understand them, and it's not going to help out very much because there is no leg opposite and adjacent to angle A. I couldn't really use right triangles very well to explain what it is that they do with them. You won't have to worry about that here. Okay. All right. I know I've spent a lot of time so far introducing this. Let's do some examples. The most basic form of examples right now is let's write ratios. Let's make sure we understand the ratios. Write each requested trigonometric ratio as a fraction here. So let's take the sine of A, cosine of A, and tangent of A. So here's angle A. I don't know its actual angle measure right here, right now, but I want to know what, for sine in SOHCAHTOA, I'll go ahead and write it. SOHCAHTOA. If I'm taking the sine of A, sine is opposite over hypotenuse. I'm going to take opposite of A over hypotenuse of A, or hypotenuse of the triangle. That is 12 over 13. That's all. I'm just going to write that. That's it. Cosine of A is adjacent over hypotenuse. Again, cosine is adjacent over hypotenuse. Adjacent is 5 over hypotenuse is 13. And then the tangent of A is opposite over adjacent. That's 12 over 5. You think you guys could do it for B? Now that B's right here, I'm not going to be drawing the arrows here, but I'm going to be pointing. The sine of B, sine is opposite over hypotenuse. Now, opposite B is not 12. That was opposite of A, right? It's relative to your angle. Opposite of B is 5. So 5 over hypotenuse, which is 13. Cosine of B is adjacent 12 over hypotenuse 13. Excuse me. And tangent of B is opposite, TOA, opposite 5 over adjacent 12. Now, whether or not you saw it on the previous screen, guys, there is a connection and relationship. The sine of A is equal to the cosine of B in the same right triangle. Is that always true? Yes. Yeah, it is. And then cosine of A is equal to the sine of B in that sense. And then these kind of flipped. There's that reciprocal thing. Yeah, that'll always happen. I don't know if that matters for you right now, but yeah, if you notice that pattern, like, hey, is that true? It is. All right, let's do actual examples. Now, I'm going to be using a calculator for these to help us out as well, guys. So here's what we're going to do. We're going to find the measure of each side indicated. The indication is with X. here's what we got, guys. We know we have a right triangle. That's good news. We can use trig functions. And we have a known angle measure. Okay? We are going to use the information provided right here to help us find out what x is. Now, we are going to use SOHCAHTOA to help us out. And you might have been wondering, Mr. Robinson, why would we have to know all three of these? Why can't we just use one of them? Well, you'll use one at a time, but you need to know all the others because it depends on the information that you have. If you notice here, guys, the only angle, besides the 90, the only angle that I know here is 37 degrees. Now, it's very possible for you to get this angle measure because you know these add to 180, but let's go with the one that we have. Let's go with the one that we have. We know this is 37 degrees right here. Okay, so this is 37 degrees. And we know that we need to find x. Now, x happens to be the leg adjacent to the angle that I know. It happens to be the leg adjacent to the angle that I know. And we also are given the hypotenuse. Which trig function uses adjacent and hypotenuse? Not necessarily in that order, but it is. The answer is cosine. We want to use cosine to help us find out what x is. So I'm going to write out an equation that looks like this. The cosine of 37 degrees, remember we're talking about the angle. When I take the cosine of 37 degrees, that'll be equal to the leg adjacent, the part we don't know, x, divided by the hypotenuse. The hypotenuse is 15. Okay, and then we're going to use this to solve for x. Now this part that I'm going to do in the calculator right now is not something I'm going to write down because it's not generally the order that I do this. What I'm going to do is I'm going to show you what cosine of 37 looks like in the calculator. Make sure you get the same thing because I'll show you how that might be different. And I just want to explain what that number represents, but I'm not going to use that number yet. I just want to explain it. So let me go to my calculator here, guys. In my calculator, here's what you first have to do in your calculator. You got to find, every calculator is different. I'm using a TI-83. You got to find out in your setup or in your mode or your options or features, whatever it is, you got to make sure that your calculator is set in degrees and not radians. When I go to something that says mode, I want to make sure that I am in degrees for this. And as long as we're using right triangles, you can probably assume we're going to use degrees. If you talk about period functions or unit circles in pre-calc, you'll probably start getting in some radian measures. But you have to be in degrees for what we're going to talk about. If you have a more basic calculator, you might have a little letter up on the top of your screen that says D or R. Make sure that you're in D. There are a lot of, I can't explain for every calculator how it is, but make sure you're in degrees. Okay? Now I'm going to type, I have a cos button. I'm going to type cosine and 37 on here, and I'm going to hit equals. Now this spits out a really weird number. You know what this number means? 0.79? Let's say it's around 0.8. Okay, let's just say it's 0.8, just to humor you on this. That means this. When I take this divided by this, I'm getting 0.8. 0.8 is about 4/5. That means that this number is about 4/5 the size of this number. How do we know that? Because your calculator knows that. Because your calculator knows trig. Your calculator understands that in every right triangle that has a 37-degree angle here, this side length will always be 4/5, approximately 4/5 the side length of this side length right here. Okay, or sorry, what did I say? 4/5 the size of this side length right here. This will be 4/5 that one. And I'm sorry for spending a long time explaining this slowly. I want to make sure you know what these numbers mean. So that's what that 0.798, whatever number, 0.8, 4/5 is in reference to. We want to figure out, hey, what's about 4/5 of 15? Basically, guys, our answer is going to be about 12. It's going to be a little less than 12. 12 is 4/5 of 15, right? Oh, by the way, I should have put to round this number to the nearest something. We're going to round to the nearest 10th if that's cool when we get our answer. So that's what that number means. So again, your calculator understands the right triangle relationship there. Just like when we did a 30, 60, 90 triangle, guys. When we do a 30, 60, 90 triangle, if this is 1 and this is, 2, this is root 3, Basically, it says we know that this side length is twice the length of this, or this is half that length. That's how 30. That's why these are special right triangles, because these are exact in this way. This and the 45, 45, 90. All the other ones are not exact. They get really weird, like 0.798 and stuff like that. But the other ones are really nice in that way. Anyway, I digress. I'm spending a long time on this part. How do I solve for x? Well, just like you would any other way, you got to get x by itself. I'm going to multiply both sides by 15. Now, notice how I said I wasn't going to use that number yet. I'm going to wait to use it at the end because I don't want to round early. So I'm going to first start by writing the exact answer, 15 times cosine of 37 degrees. This will look confusing to you, but I need you guys to understand. Cosine of 37 is just a number. Don't be intimidated by what this says right here. It's just a number. You saw the number. It's this number right here. It's 0.798. That's what cosine of 37 is. That's what it is. And it's being multiplied by 15. But I am going to type this in my calculator, and then you'll get that number out, which, like I said, it's going to be 11. It's going to be a little less than 11, 11 point whatever. So let's go ahead and check out what that is. So I'm going to type 15 times cosine of 37. And I'm going to get 11.979, right? So I'm going to first write this. 11.9795. So as a more exact, as a more precise version, it's 11.9795. If I rounded this to the nearest tenth, you know what? That does round to 12.0. Right? That's what it rounds up to. So that is round to the nearest tenth there. It is 12.0. So hey, what'd I say? It's about 12, right? And yeah, it's about 12 there. Now, I used cosine once again because I knew the leg adjacent and the hypotenuse. All right, I'm going to speed up for these next two. Here's my right triangle, and guys, x is the hypotenuse. Do not think this is the hypotenuse just because it's slanted. The hypotenuse is always opposite the right angle. So if you need to rotate this thing around, if you need to turn it around and redraw it this way, so x is right here, 24 is right here, 19, if you need to do all that, by all means, go ahead and do so. I'm going to leave it like this, and let's see if we can work off this. All right, guys, I have a 24-degree angle. I'm given the leg opposite that angle, and I'm also given, is this the adjacent? No, remember, it's the hypotenuse. It's opposite the right angle. I'm also given the hypotenuse. Which trig function uses opposite and hypotenuse? So it's so, right? S-O-H, sine. I'm going to be using sine this time to find my missing length. So I'm going to take the sine of my angle measure, sine of 24 degrees. And remember, this is just a number. What this number represents is this number divided by this number. It equals 19 over x. Whatever sine of 24 is as a ratio in the calculator, if it's 0.3, whatever it is, that means that this is that many times smaller than that. Okay. So let's just get x by itself. Whoa, I don't want to move all that. Hold on. I want to move just these ones. Let's just get x by itself here. Now, how do I do it on this? Well, I got to multiply both sides by x here to get it in the numerator to start, right? This is algebra, guys. The rest here is algebra. I got to multiply both sides by x, and then I got to divide both sides by the sine of 24. So now I'm going to divide both sides by the sine of 24. You know what essentially happens here, and you'll probably hear me say this more often down the line, is basically x and the sine of 24 switched places. Now this is going to say x equals 19 divided by the sine of 24 degrees, like that. And yeah, so see, x was down here. Now it's up here. Sine of 24 was up here. Now it's down there. They kind of just switched places. You'll probably hear me say that more often. It's kind of like a magic step. But okay, there's the exact answer. Let's go ahead and compute that one. What is 19 divided by sine of 24? Even I don't know. I'm not even going to guess. Make sure you're in degrees on your calculator. And it's that number, 46.713. I'm just going to go ahead and write 46.7. X is about 46.7 units there. That is how long that hypotenuse is. Now, one thing I will ask you to do, listen, I didn't know this answer. But I will give myself a reality check and say, does the answer make enough sense that, that is that answer reasonable to me? The first thing I'm going to check is, as it's a hypotenuse, was it at least longer than this side length? Yes. See, if I get something shorter than the side length, I know something went wrong, right? Hypotenuse should be longer. Not only should it be longer, but because this angle is more acute, that means this side is relatively shorter than the hypotenuse. It makes sense that it's getting a little longer. It's not just 20, it's not just 25. It's not just 4/5, the side, like what I mean. It's going to be a little bit longer there. So as a reality check, I'm going to trust the answer a little more. So I might not know the answer's right, but I probably would be able to tell if the answer's wrong, and I can't tell if this answer's wrong here. This answer doesn't look bad to me. All right. Last example for these side lengths here. Let's try and find out what x is given this angle measure. And we have this side, which is leg, which is opposite. And we also have the leg adjacent. Opposite and adjacent. What uses opposite and adjacent? SOHCAHTOA. Tangent uses opposite and adjacent. So I'm going to take the tangent of my angle measure, tangent of 54 degrees here. And I'm going to do opposite, which is 87, over adjacent, which is my unknown x. You guys remember how I said that when I solve this thing, that x kind of switches places with tangent of 54? Could I do that and have you understand it? Here's the thing. I don't want you to switch places when you're not supposed to. For example, here it didn't switch places because x was already in the numerator. It's a different story. So if you understand the switching places thing, great. If you don't, use these two steps. Or set up a proportion and cross multiply. Do something else, but do not put yourself at fault just because I said the switching places thing. I want to save time for those who know how to save it. All right, but I got to do 87 divided by tangent of 54. So let's go at that. 87 divided by tangent of 54. 63.209. I'm just going to write 63.2. X is about 63.2. Okay, one more reality check before I move on to the next slide here, but I wrote 63.2 here. Okay, so last thing I want to say here. Now, does this answer make sense? Well, here's the thing, and we haven't really talked about the other angle yet. Guys, if this is 54 degrees in a right triangle, see, these two angles are complementary to each other. 54 plus this has to be 90. So this is 36 degrees right here. 54 plus 36 is 90. We talked about how the longest side is always opposite the largest angle. Well, it's also true that the smallest side is always opposite the smallest angle. Does it make sense that 87 is more than 63.2 if 54 is more than 36? Yeah. 36 is a smaller angle measure, so 63.2 should be smaller than 87, right? So that, at least that makes sense to me when I'm doing that double check. So if I got an answer that was larger, then okay, then I made a mistake. Now, should it be significantly smaller? I mean, these angles aren't really, I don't know. These angles are kind of close-ish. They kind of get closer to 45, right? So these are kind of close-ish to each other. It's not like this is like, 10 units or something. So anyway, just kind of double checks because you're going to make mistakes on your calculator. You're going to accidentally multiply when you should have divided, things like that. All right, that is the trig ratios in finding side lengths there with SOHCAHTOA. This part will be a lot faster now in finding angle measures, so let's go ahead and check it out. All right, but it's, some of the stuff's going to look a little confusing here. Okay, like all other mathematical functions and operations, guys, trig functions also have inverses. What I mean by that is addition has subtraction as an inverse, multiplication has division as an inverse, squaring something has square roots, things like that. Trig functions, taking the sign of something, you can also go backwards and, get something back. And it's what's called inverse trig. Inverse trig functions are called inverse trig. They're represented with this really weird notation, guys. It looks like it says sine to the negative first power. Not only does it not say that, it also doesn't mean that. If you know what negative first power means, like x to the negative first power is 1 over x, that's not what this means here. So honestly, I'm not a big fan of the notation. There's also another way they do it. It's called arc sine. and arc cosine. Well, there should be two C's. Arc, excuse me, arc cosine and arc tangent. But I believe on your calculator, you're going to see these ones here. But if you ever see these are the same thing. I prefer these because they're not confusing with the negative first power. But they're interchangeable. So this does not mean, and if you say this out loud, you are incorrect. This does not mean sine to the negative first power. This is just called inverse sine. Inverse sine, inverse cosine, and inverse tangent, or arc sine, arc cosine, arc tangent. There's a reason why they call them arc. I'll say it in a second. They can help you find angle measures if you know the appropriate sides relationship. So why is it called arc sine? Because an angle has a certain arc measure to it. So that's what you're trying to find, guys. Before we took the sine of an angle to find out a ratio. Now we're going to take the inverse sine of a ratio to find an angle. So this time, guys, we're going to know what the side lengths are. And given the side lengths in that right triangle, we're going to figure out what the angle measure is. Kind of sweet. You can work the other way. So angle A, whatever angle A's measure is, I could find it in one of three ways. It depends on which side lengths I'm given. If I knew the opposite side and the hypotenuse, I would use inverse sine to figure it out. But if I knew the leg adjacent and the hypotenuse, I would use inverse cosine to find angle A. And if I knew the side opposite and the leg adjacent to it, I would use inverse tangent. Now, if you knew two of any of the three sides, you could always use Pythagorean theorem to find the third side, and then use any of the inverse trig functions that you want to. I'm going to refrain from that, though. One of the reasons besides the fact it takes longer, but one of the other reasons is if you have to approximate that third side, or if it's a weird irrational number, it's just not worth dealing with. Angle B is going to be the same way. If I want to find B's angle measure, I could use inverse sine if I knew its opposite in hypotenuse. Again, its opposite. Or its adjacent over hypotenuse, I'd use cosine. Remember, SOHCAHTOA when I'm saying all this stuff. And then tangent, opposite over adjacent, if I knew those things. So let's take a look at a couple examples here. See what the heck we're talking about. By the way, in your calculator, you still have to be in degrees. If you're not in degrees, if you're in radians, your number's not going to make any sense. Find the measure of each angle indicated based on the examples. Here I have a diagram. We want to find the measure of angle Y. Angle Y is right here. This is our unknown. In a right triangle, knowing this information will let me figure out what this angle is here, right? See, if I took, and I'm going to write this out in the general way that we were before here, meaning with the basic trig function that we had before. If I know the leg adjacent to Y and the hypotenuse, we should be using cosine. So if I were to take the cosine of, I'll just put Y. I'm not going to say measure of angle Y. But if I were to take the cosine of Y, actually, no, you know what? I am going to put measure of angle Y. If I were to take the cosine of the measure of angle Y, I would get 14 over 23. That is adjacent over hypotenuse, right? Now, I'm going to separate, not that, I'm going to separate some stuff here because of what I got to do next. What I got to do next here, guys, is I got to find out angle Y. And here's what you don't do. Do not say something like, to solve for measure of angle Y, I divide both sides by cosine. No, that makes no sense in a lot of ways. The first thing is cosine is not a number. Cosine of an angle is a number, but cosine is not a number. Cosine is a function. That's like saying divide both sides by square root. That doesn't make any sense. Divide both sides by the addition sign. Huh? Yeah, you can't just divide both sides by cosine. What you can do is take the inverse of cosine. How do you do that? You literally do that. You take the inverse cosine of this side, and you take the inverse cosine of this side. Now, the inverse cosine of measure of angle Y cancels out the cosine stuff. You're left with measure of angle Y. And the measure of angle Y equals once again, the inverse cosine of 14 over 23. Now, I'm going to use my calculator to compute this part. And when I do, it's going to spit out a number. That number will represent the angle measure. So let's try that. Let's take inverse cosine. Now your calculator, for me, it's above my cosine button. I have to hit the second button. It's like a shift. I have to hit the second button to do it for mine. I don't know what yours is going to be. I can't say. But it's going to look like that. 14 divided by 23. And as long as I'm in degrees, right there, then it should give me the number I'm looking for. And my number is 52.5 about. I'm going to round to the nearest tenth. So measure, you don't see this right now. I'm going to write it first. Measure of angle Y is about 52.5. Now this is degrees because this is an angle measure. Remember, I just found, here we go. This is in degrees. I just found the angle measure for Y, 52.5 degrees about. Okay. Once again, Trig determines these things for you. Very spiffy. Measure of angle Z. Hey, I could find Z by doing 90 minus 52.5 because that's how these things work. And if I do, I get, what, 37.5? Boom, there's my answer. I solved it. There's nothing wrong with that. So if that's all you had to find, boom, you got it. But I'm going to confirm I get 37.5 by using inverse trig. One more time, guys. On Z, I know the side opposite of Z, and I know the hypotenuse. Opposite over hypotenuse in SOHCAHTOA is sine. So, S-O-H, sine is opposite over hypotenuse. So if I'm taking the sine of the measure of angle Z, that's going to be, once again, 14 over 23. Now, the same thing's going to apply as before, guys. I'm going to take the inverse sine of both sides, just like I took the inverse cosine of both sides here. And when I do, what happens is the sine cancels out on this side, and then the inverse sine appears on this side right here. Now, you might ask, can I just write this to start with? Yeah, you could. I recommend you start off with the ratio that you're very familiar with writing to start off with. I think you're probably going to find angles less often than you're going to find sides. So probably start off with the ratio here first when you're doing things, and then just work from here after. Heck, write this if you need to. But the measure of angle Z is the inverse sine of 14 over 23. So will I get the same number as this one, inverse cosine? No. This time it's going to give me this angle instead of this angle. Mr. Robinson, you used the same ratio as before. Yeah, but it's a different trig function, and your calculator's aware of that. It knows when it says 14, it says, you're doing the side opposite this time, aren't you? You're not doing the leg adjacent, huh? So, hey, I know what that looks like in a graphing calculator. So they're going to do we're going to do the inverse sine of 14 over 23, and they're going to give us about that 37.5 number, right? 37.49. I get to round that up to 37.5. So the measure of angle Z is about 37.5 degrees. Now, the only danger that could present itself, it won't for these, but the only danger that could present itself in finding that other angle by doing 90 minus whatever is because I rounded early on 52.5. You never want to use an early rounded number to get another answer, right? In this case, when it's just addition or subtraction of a single number, it's not going to affect it. So yeah, that's 37.5 degrees right there. So we found both angle measures. 37. Oh my gosh. I put there we go, 37.5 degrees. All right. There are those. One more example, and then we're done here, guys. We got measure of angle A, knowing 19 and 36. What are these in relation to A? 19 is the leg opposite angle A, and 36 is the leg adjacent to angle A. We aren't given the hypotenuse at all. Opposite and adjacent, we use tangent. So let's give that one a shot. Tangent. The tangent of the measure of angle A equals 19 over 36. So the inverse tangent of both sides will get measure of angle A by itself, and we're going to be taking the inverse tangent of 19 over 36. Calculator. Now, before I compute it, not just because of the drawing, but remember what I said about these two sides here. Well, actually, here, if these two sides were the same length, then this would be 45 and 45, right? It'd be an isosceles triangle. Because this side is, well, actually, let me write those again. Because this side is less than this side, I expect an angle that's going to be smaller than this one here. That means this needs to grow larger than 45. That needs to grow smaller than 45. I expect an answer less than 45 is basically all I wanted to say here. Now, to the question that I asked before, 19 is about half of 36. Does that mean this angle will be half of this one? No, that's not how angles work with it. We'll use the trig to answer that question. So, I'm going to go to here. Let's take the inverse tangent of 19 over 36. And we will get 27.82. So, about 27.8. Measure of angle A is about 27.8 degrees. So yeah, all these rounded to the nearest tenth, I suppose. That's going to be kind of a good way of going about this. That's once again 27.8 degrees. And if I did 90 minus 27.8, I get this one. It's about, what, 62.2, I guess, like that, degrees. So yeah, not twice as much. Right, it's a different amount there. Anyway, there's that one there. And that's how we use inverse trig. So you're going to need a scientific calculator. You're going to have to make sure you're in degrees. You're going to have inverse trig functions available to find these angle measures. And hopefully that inverse trig stuff did make sense. So that's it, guys. That's it for this video. There may be another video coming up on some more, not advanced trig, but using trig in word problems and using trig in non-right triangles to do something specific. That's kind of all I can talk about there. All right, that'll be it, guys. This is Mr. Robinson. Thank you. Take care.